Hello students, this video is for the Unit 1 Lesson 3 on vertical angles and ASOP, which stands for angle sum of points. We're going to be talking about two other strategies to figure out missing angles in diagrams using what information you are given in the diagrams. Let's first take a look at the learning target. In this case, the learning target is I can apply concepts of vertical angles and angle sum of points, remember that's ASOP, to determine angle measures. Just like with complementary and supplementary angles, we're going to be identifying relationships within sets of angles and trying to use those relationships to figure out the answers to the questions. For right now, take a look at the do now questions. It should take you a couple minutes. Try to answer these questions and use evidence for your answer. Make sure you write down why you say the answers. For this first problem, for the second problem, it should be fairly straightforward. I'm looking at a straight line and a line that is sort of cutting that line into two non-equivalent angles. Those two angles are next to each other, adjacent, and they form a straight line, so they are supplementary angles, which means these two angles, the y and the 121, add up to 180 degrees, which means I subtract 121 from both sides. I get y is equal to 59. That was fairly easy. It was from the last lesson. In this case, what I could do is use supplementary angles several times. I could first identify that these angles form a straight line, so this 36 and whatever this happens to be sum to 180, which means this angle here is 150. And then once I have this angle, I can use the supplementary angles theorem again to say, well, if that angle is 144, this straight line, which is cut by this ray coming off of it, can also be supplementary angled. Here's how it looks. So if you see when we did the supplementary angles theorem, we added 144, which is this angle here, and this x angle to get 180, and we solved for 36. That should be a little bit familiar to you because this angle here and this angle here are both 36. Moving on to this last one, I can see that there's an 82, 172, and a z here. I don't see any straight lines and I don't see any right angles, so I can't use complementary and I can't use supplementary, but I can use something else. You should be able to draw a circle around this whole entire figure, considering that that point is at the center. And from that center, we have three different angles. And you should recognize a circle has a certain number of degrees in all of the inside angles, the interior angles of it. That number is 360. 360 degrees is associated with a circle, which means that all three of these angles should add up to 360. That's a concept we're calling ASOP, or angle sum of points. But before I give this one away, I'm going to scroll down to where it says vocabulary. For the vocabulary, let's define vertical angles. We have here that a pair of angles that are formed by two intersecting lines that share a vertex but no sides are called vertical angles. They are also referred to as having equal measures. This is a vocabulary word, which I'll give you in a minute, that is something that will come up over and over again over the course of this class. Let's take a look at the diagram. Okay, in this diagram you should see that we have two intersecting lines, and they intersect at this point here. We're looking for a pair of angles that are formed by these two intersecting lines that share a vertex but no sides. So I'm identifying this angle first. Now I'm looking for another angle that shares the same vertex but no sides. It can't be this angle, and it can't be this angle, because both of those angles share a side with the angle that I drew here. It's actually going to be this angle here. Sometimes students refer to this vertical angles as the bow tie theorem. It kind of looks like a bow tie when you're, I guess, a math teacher and you have no other better jokes to tell. Anyway, vertical angles are across from each other, and they are equal to each other. They have equal measures. I almost said the vocabulary word, which I'll write down right now. That vocabulary word that I wanted you to know, which means equal measures, is called congruent. When two figures have equal measures in geometry, we refer to them as congruent. And we can use this for a lot of things. We can use it for angles. We can use it for line segments. We can even use it for more complicated figures like triangles and quadrilaterals and things like that. But that'll come later. For right now, I need you to know that congruent just means they have equal measures, whatever method they use to measure. An angle sum of point, or angle sum of points, is, well, the definition's coming up right now. All right, and here's that definition for angle sum of points. All angles from a shared vertex sum to 360 degrees. In order to envision this all angles from a shared vertex concept, let's go back up to the do now for a second. We can see that all of these angles, the z, the 82, and the 172, are all coming from this same shared vertex. Since all of these three angles share a vertex, they're considered to be coming from one point, and the sum of all three of these angles should be 360 degrees. Here's the diagram. Here's the idea that you should be getting with this. When I'm drawing rays or line segments away from a point, and they're all from the same point, that same vertex, it doesn't matter how many angles that are formed. I could form 5 angles or 3 angles from the previous example, or 2 angles or 6 angles or 100 angles. Whatever the case may be, all of the angles around a central point sum up to 360 degrees. Let's actually try to apply this fact to the do now. Take a moment, pause the video, and see if you can use this fact, this angle sum of points fact, in order to figure out the value of z here. Alright, you'll see just like in previous examples, I wrote down the concept or the formula or theorem that I was using, angle sum of points. I wrote down a bare bones formula for it, and then I substituted in the stuff that I knew. Then I was able to solve that z is equal to 106 degrees. Just like using supplementary angles or complementary angles, I'm able to write down angle sum of points for that same thing. As a matter of fact, for this example back here, I didn't need 2 supplementary angles. I could do it a quicker way. Here's that quicker way. If I'm able to identify that 2 lines are intersecting with each other and the angles across from them are created by that intersection, I can say, well, angle is equal to angle. So that means 36, which is one of the angles, is equal to x, which is the other one of the angles. And then I'm done. That's very much quicker than doing 2 steps. Moving on to the next page, let's take a look at the model example. Just like with any one of these problems with trying to figure out which of the topics to apply, you need to understand what's going on in the diagram. It looks like in this diagram I have one central point, which is here, and then I have a lot of angles coming off of it. So you might be tempted to use angle sum of points. However, I don't know this angle, I don't know this angle, I don't know this angle, and I don't know this angle. I do know these 2 angles. I know this angle here, which is 2 plus 3x, and I know this angle here, which is 62 degrees. Not seeing it yet? Maybe I'll draw it in for you here. I have 2 straight lines that intersect at this point, and they create 2 angles that share a vertex and don't share any common sides. This is a situation where we can use vertical angles, which means I write down the concept, vertical angles, and I say, well, vertical angles means that an angle is going to be equal to the other angle. That means all I have to do is substitute my information in here and solve for the variable. So here you can see I substituted the angles into the equation and then solved the equation using algebra, which it's not my job to teach you, so figure it out. However, at the end of the problem, you get x is equal to 20, which means we've answered the question. It asks us to find the value of x, and we have done just that. In the next question, it asks us to find the measurement of angle ECD, and we have a couple of pieces of information here. We have this angle, which is ACB. We have this angle here. If you didn't see that, that is a right angle, and we just don't know ECD. So we could use a couple of different methods for this, but let's try to use the angle sum of points. So I'm able to say that this angle, this angle, this angle, and yes, even this angle over here are all emanating from this same vertex. They all share that same vertex. And all of these angles, 1, 2, 3, 4, they're going to add up to 360 according to the angle sum of points. So let's take a look at what that looks like in the equation. And here I tried to color code it a little bit so you saw what was going on. This angle, this green angle, 72, plus this red angle, which is 90. Remember, there's a right angle mark in there. Plus this purple angle, which is ECD. The only one I don't know, which is why I kept it as angle ECD. And then 180. Angle ACD is a straight line, or a straight angle, which is 180 degrees. All of those 4 angles together equal 360 degrees. Now we just have to do a little bit of algebra to solve for ECD. Combining like terms on this side, we get 342, and then subtracting 342 from 360, we get 18. So there's our answer for that second model problem. All right, folks, your responsibility now is to take a look at the individual practice and try to answer these questions. This was the video on Unit 1, Lesson 3 for vertical angles and ASOP. Good luck studying.